All right, nerds and nerdsettes, let's go. The mole, Avogadro's number. Okay, we did this yesterday. 6.02 times 10 to the 23rd power. Okay, that's a counting number. That's how many atoms we have in 1 mole. Okay, molar mass, which we've highlighted on our sheet down here in yellow, is the mass of 1 mole of any pure substance. Okay, so if we have a mass of gold, it has 6.02 times 10 to the 23 atoms. All right, let's talk a little bit about molar mass. The molar mass of an element is always in grams per 1 mole. Okay, this equals the atomic mass of the elements in grams. So if we want to take a look for an example, periodic table, beryllium 9.01. Our 2 says stay the same. So 9.01 grams is how much 1 mole of beryllium would weigh. If we want to do a molar mass of a compound, okay, like water, H2O, this is going to equal the sum of the molar masses of the elements making up that compound. Okay, so we've already practiced this. So this is where oxygen would be 16. Hydrogen is 1.01, but there's 2 of them, so we times it by 2. Okay, so the molar mass of water would be 18.02 grams for every 1 mole. So if you weigh out exactly in a cup 18 grams about of water, okay, that's how we would have this many molecules in it. Okay, all right. This is practice of molar mass. We've done that, and go ahead, do those problems. We're going to go down to the bottom of the page where we have something new. This is where we're going to be converting. Okay, so number 2 says how many moles of atoms are there in 8 grams of Mg? Okay, and here we have magnesium. So first thing you're going to do before you any problem is we have to highlight everything. We want to know how many moles of atoms are in 8 grams. Okay, so the first thing we need to do is figure out the number, what we're starting with, and what's our unit. Because we have grams, we know we are starting here at green. We're at mass. Okay, and the question is asking how many moles. If we look on here, pink. We're going to go from green to pink. That's how we're going to do this problem. In order to do that, we have to do this step. We're going to times it by a mole, and we're going to divide it by the molar mass because it's on the bottom. Anything on the bottom is division, anything on the top's multiplication. Okay? So on here we have 8.0 grams. Always start with the number in the problem. Okay? And we're going to highlight that green. We want to go to pink. How many moles? That's what we're asking for. And to get there, we need to look up the molar mass of magnesium. Okay? So we're going to start with 8.0 grams. Okay? Draw a line. Once again, there's nothing underneath this first box. We have a 1 unit number. So you can cross it out. You can put 1 underneath it, but nothing's going to go at the bottom. Okay? Take a look at our first step. We want to divide by the molar mass. Okay, I'm going to put a multiply here. We want to know the weight of 1 mole of magnesium. Zoom, 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 zoom. And if we take a look at magnesium on our periodic table, we have 24.312. Once again, we're always going to round to 2 decimal places, 24.31. That's what's going to go on the bottom, the molar mass. 24.31 grams. Okay? Molar mass is always done in grams per mole. And we can write that either direction. We can write the mass on the top per mole, or 1 mole weighs 24.31 grams. Okay? And let's see what cancels out here. So if I take a look here, grams and grams are gone. That's another good key that we're setting this up correctly. Okay? And there's no unit here. We're left with moles. How many moles? What we're left with is matched up with what we're asking. We know we've done this problem correctly. So now, 8.00 divided by 24.31. And here's our answer, 0.329082682. This would be moles. We don't need that much, okay? So if we route that, we're gonna write this two different ways. First, out of scientific notation, and then in scientific notation, okay? So we have 0.329 moles of magnesium. Circle answer. Let's put this in scientific notation. Right now, this number, 0.3, is less than 1. We're not falling between 1 and 10. So we need to move our decimal to here. So that way it's 3 point. We want 2 more decimal points, 29. Our 0 tells us to stay the same. Okay? Because this is a small number, we're less than 1, our exponent should be negative. So we would write this as 3.29 times 10. Once again, this number was small when it was out of scientific notation. So we're going to write it as to the negative first. Same thing, you have to have a unit. This is still moles of mg. Okay, so this is our number in scientific notation. Okay, let's do another problem. Okay, so down here, let's do number 3. How many atoms are in 0.7 grams of helium? Okay, so for atoms, if we find this on our sheet, we have mass, we have molar mass, we have moles, we have atoms. Blue is the one we're going from. Okay, we want to know how many atoms. Okay, we have 0.7 G's, grams, and our element is helium. That's what we're going to pull off the periodic table. Okay, we always have to start with our number. Okay, so our number is 0.7 G's. 0.7, I'm going to add a decimal point, 0 grams. We'll put that over 1. Okay? I want to go from here to green all the way over to blue. Okay? I can't jump across. There's no arrow that does that. Okay? We have to first change it into moles. I have to know how many moles I have before I can figure out how many particles I have. Okay? So we are still going to do green to pink this first step. We're going to divide by our molar mass again. So here we go. And we're looking at helium. So 1 mole, molar mass of helium. 1 mole of He. And on the bottom, let's take a look. 4.003. So we're looking at 4.00 grams. Everything on here is in grams per 1 mole. So we have 4.00 grams per our 1 mole. Okay? So if we stop here, cross out grams, okay, we'd be left with moles. How many atoms? That's how we know we're not done. These don't match up yet. We need another step. So we're now going from moles, which is pink, and we're going to our blue step. Blue. Okay? So in order to do that, if we're going from pink to blue, we're following this bottom arrow. We're doing this. If we had started with number of molecules, we'd be doing this. Okay? So on this problem, to get from pink to blue, we need to multiply by Avogadro's numbers. The number of, we can change this word particles with anything in here. And we're working with, let's see, atoms. Okay? So we're going to say that we're going to multiply it by 6.02 times 10 to the 23rd atoms. Let's do that now. 6.02 times 10 to the 23rd power. And on the bottom, we want 1 mole of helium. Remember, 1 mole of anything always has this many atoms. Okay? So now, let's take a look at our problem. Grams and grams canceled out. Moles of helium is about to cancel out. And we're going to be left with this many atoms. Okay, so if we're looking at this entire problem, we're going to take this number, divide it by 4, and then we're going to multiply by Avogadro's number. Let's do that now. 0.70 divided by 4.00. I'm going to hit equals. And then we're going to multiply by 6.02, okay, exponent 23. Don't do the times, caret, parentheses, any of that nonsense. That's how we want you guys to type in exponents. 6.02, exponent key at the bottom, 23. And here we go. Okay, so we have 1.0535 times 10 to the 23rd. And this is already in scientific notation for you. Okay, we want to keep 2 decimal places, 1.05. The 3 tells us to stay the same. So our answer will be 1.05 times 10 to the 23rd power. Okay, if you leave it like this, I'm going to write the word tacos next to it. I'm going to say that's a lot of tacos. You have to have a unit at all times. Look at your problem. We want to know how many atoms. That's what you should be ending with. Atoms, and if we want to be more precise, we can say atoms of helium. Last thing you have to do is you have to circle your answer. Okay? This is how you do dimensional analysis. This is how we are doing converting. We're rounding. We're doing scientific notation. We're doing lots of good stuff on here. And now we're going to do some more practice. Enjoy.